Ever wondered how your phone recognizes your face almost instantly every time you unlock it? Or how it seems to get better at recognizing you, even in different lighting or with a new haircut? Or maybe you've noticed how streaming services seem to know exactly what you want to watch next, suggesting shows and movies that match your taste, even before you realize it yourself. The answer to these everyday wonders often lies in artificial neural networks, powerful systems at the heart of modern artificial intelligence. Inspired by the structure of the human brain, these networks are made up of simple units called nodes, or artificial neurons, all working together in layers to solve complex problems that would be impossible for traditional programming. Instead of programming every single rule, we let the network learn from examples, like showing it thousands of cat and dog photos until it figures out the difference on its own, learning patterns and features that even humans might miss. This learning from experience approach is what makes neural networks so powerful for tasks that are hard to define with strict logic, allowing them to adapt and improve as they see more data. Bernhard Mehlig's book, Machine Learning with Neural Networks, breaks down these concepts in an intuitive and accessible way, guiding you step by step from the basics to a deeper understanding of how these systems work. It's perfect for anyone curious about how these digital brains operate, especially if you have a background in science or engineering and want to explore the fascinating world of machine learning. The journey starts here, understanding how machines can learn, adapt, and make predictions about the world around us, opening up endless possibilities for innovation and discovery. So, how do neural networks learn? It's all about minimizing mistakes using math. A loss function scores how wrong the network's predictions are. The goal, get that score as low as possible. To do this, networks use gradient descent. Imagine feeling your way downhill in the fog, always stepping toward lower ground. Backpropagation helps by tracing errors backward, showing which connections need adjusting. This cycle, predict, score, adjust, repeats thousands of times, gradually improving accuracy. Mehlig's book makes these ideas clear, using worked examples to show the math in action. You'll see intimidating terms like gradient descent and backpropagation become practical tools. By the end, you'll know how to train your own learning machines. One of the most fascinating parts of Mehlig's book is the unexpected bridge it builds between two seemingly different worlds, artificial intelligence and physics. The book reveals how neural networks are deeply connected to statistical physics, a field that explores the collective behavior of large systems. Both disciplines investigate systems made up of many interacting parts, whether it's neurons communicating in a network or molecules bouncing around in a gas. Training a neural network, Mehlig explains, is remarkably similar to a physical system finding its lowest energy state. Minimizing loss in machine learning is like searching for the most stable configuration in physics. This powerful analogy allows scientists and engineers to apply well-established physics concepts, such as energy landscapes and equilibrium, to better understand and optimize neural networks. It's not just a neat comparison. It actually provides practical analytical tools and mathematical frameworks for studying these complex systems in depth. Mehlig encourages readers to move beyond treating neural networks as mysterious black boxes, and instead use scientific principles to truly grasp how and why these models function. By adopting this perspective, you can unlock new ways of thinking and empower more creative, effective problem-solving with machine learning. The dream of thinking machines began decades ago, with early models like the perceptron in the 1950s. These pioneering efforts captured the imagination of scientists and the public alike, as people wondered if machines could ever truly think or learn like humans. These simple networks sparked excitement, but their limitations soon became clear. When early hopes faded and progress slowed, the field entered what became known as the AI winter, a period marked by skepticism, reduced funding, and stalled research. The breakthrough came in the 1980s with the discovery of backpropagation, a powerful algorithm that allowed deeper networks to learn from their mistakes and solve much more complex problems than before. This reignited interest and opened new doors for AI research. The modern era, deep learning, was fueled by the explosion of big data and the advent of powerful GPUs. These advances made it possible to train networks with hundreds, even thousands of layers, unlocking capabilities that were once unimaginable. Today, deep neural networks excel at a wide range of tasks, from image recognition and language translation to playing complex games like chess and Go. These achievements have ushered in what many call a golden age of AI, transforming industries and daily life. Mehlig's book traces this remarkable journey, showing how each advance built on the last and how setbacks often paved the way for future breakthroughs. Understanding this rich history helps you appreciate not only the power and potential of today's neural networks, but also the persistence and creativity that made them possible. Neural networks aren't just theory, they're transforming science and engineering. In medicine, they analyze scans to detect diseases with expert-level accuracy, helping doctors save lives. Engineers use them for predictive maintenance, like forecasting wind turbine failures before they happen. In materials science, they predict properties of new compounds, speeding up discovery. Mehlig's book stands out for its practical focus, offering hands-on exercises and real-world examples. You'll learn to build and train networks using Python, bridging theory and application. Whether you're a beginner or an expert, the book equips you to innovate with neural networks. It's your guide to understanding and shaping the future of machine learning.